Hi everyone, welcome back to my YouTube channel. This is going to be part 22 of our Snowflake Zero to Hero series. In this video, we will be discussing about the crucial Snowflake topic, which is zero copy clone. This feature is going to be very important in your real-time project implementations because this is not just going to save your time, cost, as well as it's going to save a whole lot of your headaches. Because if you remember, when we were working on premises and your client or basically your team says that, okay, hey, you have to do some lot of testing on your data on this table, then we usually go for the backups. So if my data is if I do have some bad data in my production environment, I need to take the backup of it, and then only I was able to create some kind of a testing, or I was able to create some modifications, some DML operations and all. But that was again creating a problem for you, that if you forgot to delete those unwanted backups, then it is going to create a storage issue. But in Snowflake, we don't need to worry about any of this. So the zero copy clone in Snowflake is basically allow users to clone database, schema, or table quickly, and one important thing, that without any additional storage cost. So if I have 1 terabyte of table in my production environment, and my manager is saying that, hey, can't you just clone it and then do some DML operations and just figure out that why the numbers are not matching, then I can simply clone that into the lower environment or into the same production environment only, and then I can apply some my analysis without worrying of additional storage cost. So what's more of like how we are going to clone it, and how exactly we will be seeing it, that okay, that whether it is going to consume any extra credits or not, and in which scenario if I'm going to clone it, and if when it will be charging extra from our side, and what if I'm going to delete my parent object, then how it is going to behave to the cloned object or the child objects. So let's understand how exactly it works in the backend. So just imagine that if you are if you have already understood, this is this the architecture, Snowflake architecture. This is cloud service layer, this is virtual warehouse layer, and this is storage layer. Now in the storage layer, we know like if I'm going to insert a one big file, that will be creating micro partitions. Now, if this is one table, let's say T1, this is a one big customer, or like one T1 customer table, or you can simply say order or anything. Let's say now this T1 is having a three micro partitions, which is basically size of 50 to 500 MB of uncompressed data. So usually in Snowflake, it will be less than these because Snowflake generally compress the data. Now, the Snowflake in the cloud service layer keeps the metadata here. So these are the metadata which basically holds the information about these micro partitions. Now, if I'm going to query anything, let's say select max, select count, or select sum, then this cloud service layer is only going to return the information. Now, if I'm going to clone it, then the Snowflake does not actually clone the micro partitions. Snowflake rather than will be creating a separate metadata copy, but will be referring to the same micro partitions. So Snowflake is intelligent enough to understand that, hey, they are just trying to clone the data which is already there, which is already into my storage layer. That's why they are just going to create a separate metadata copy. And for that, it only and only happen into the cloud service layer. No like virtual warehouse comes in the pictures, and thereby it's not additional storage cost. So no additional storage cost associated with it. Let's see that. Now, if I come here, if I see, like, sorry, this, let me actually show it to you that, okay, right now I do have this analytics bootcamp database. And in that database, I have a branch layer schema. And in that schema, I have tables, stages, file format, and pipes, these many objects. My compute warehouse is right now sleeping. So let me just do that. Create or replace database, and then I'm not like analytics bootcamp cloned. And then for this, I'll just simply use clone keyword and then going to use analytics bootcamp because I wanted to clone this particular database. So if I'm going to run it now, this took 3.3 seconds, and you see the warehouse is still suspended. The database analytics bootcamp clone successfully created. If I'm going to refresh it, I can see that there is another database for me. Now, if you will look at it, you will be having the same branch layer, information schema and public, those three schemas we have. Inside the branch layer, we have table, stages, file format, and pipes. So I do have all the objects which I have created in the bootcamp. This is how you can create your database. Now it took only 3 seconds with depending on the size. If your data size, if your table is huge, then it may take like couple of minutes depending on the size of your database or your tables. If you're going to clone your database, it is going to clone the other child object also. However, one important thing, if you're going to look into this, that if I'm going to expand the stages, here I have 5 stages. But if you will expand the stages inside your cloned database, then you will be finding only 2 stages. So that means it is not going to clone your internal stages. And second, it also not clone the external tables. Okay, now that's how you can just simply, like, if you wanted to clone, let's say, the schema or a table, simply you just need to use that word or like that date create or replace table, and then you are going to clone it. Now, so one thing we have understood. So let me just take one table. Okay, I'm going under this analytics bootcamp only, and this is my branch layer. Now I can just let me show it to you to take a clone of any table. Let's say this employee table. So what I'm gonna do is create a replace table, employee table clone, and then I'm just going to use clone as keyword and going to. Now, if I'm going to write show tables, this is an employee table clone. So I mentioned this one thing to you that if you are going to clone the tables or the database, Snowflake will not be charging any storage cost from your side. But this is not the right place to look at the storage or associated bytes. Because if you will look at it, both are showing 9943 records and even the bytes. The actual place, if you want to find out whether it is going to take any charges from your side or not, you need to go into select star from information schema dot table storage metrics, and then you can basically go and mention your like database name. So I can here table catalog equal to analytics bootcamp, and you will find this employee table clone. So this is employee table and this is employee table clone. This is we have created. Now if I scroll to the right, you will find the active byte is 0. So that means Snowflake is aware of the fact that this is something created by the this is a clone table created by the user, and how we will be knowing it that this is referring to any parent table or not. Now focus on these ID and the clone group ID. If this ID and the clone group ID is same, that means it's not a cloned one. But if you will look at it, this ID is a unique ID number created by the Snowflake or assigned by the Snowflake to every table. However, this clone group ID is going to refer the parent table. If it is cloned, then this clone group ID will be the ID of the parent table. Now, if I see this employee table clone is 26626, but the clone group ID is not same. That means it is referring to 5604. So if I look at it, 25604 is nothing but an employee table. I can directly like see it because I have created. However, if someone else in from your team has executed this task, then you can simply get to know with the help of this ID and the clone group ID. You can even write a query like where ID equal to clone group ID, and you can find out the table name. And with the help of inner join, you can write your own query statement. Okay, so as I can clearly see it, there is an active by its 0. That means this is not going to charge any storage cost. But until when? If I'm going to now make any changes in this employee table clone, if a user make any DML operations, then the Snowflake will charge. So what exactly happened? I'm coming to this point. There we have seen it that the snowflake is actually. Let me take another color for you. This is a green color. Okay. So snowflake initially for this micro partitions for this for this metadata, and this metadata is referring the same in existing micro partitions. We know it that the micro partitions are immutable. Now, if you have created, this is a clone table and this is an original table ka metadata. Now, if I have added 10 records, then it is going to have an additional micro partitions, and this is just going to be referred by this metadata because this is a separate micro partitions and this is for cloned one. So if you think that the clone will never ever be getting charged, answer is no. The Snowflake will not be charging any storage cost until unless you make any changes in that. So as soon as you are going to make any DML operations, it is going to add a new micro partitions, and those bytes is going to be charged by Snowflake for that particular cloned object. And once you see that you're going to make any DML changes, and here you will be seeing some bytes. Now, the next point is, okay, so after this, we can see there is a charges and all. Now, next point is, if I am going to make any changes into my parent object, that means if I'm going to make any changes into my this employee table, will it be impacted in this employee table clone? Answer is no. So each of these objects is independent of each other now. So you can just imagine that this employee table clone was the snapshot of this employee table. So if I am going to add any new records or going to delete it or even going to drop it, it's not going to be impacted. Let's do one thing. So what I'm going to do is I am going to truncate the table, employee table. Now, if I'm going to write select star from employee table, it is having 0 record, but we have created a backup. This should have the data. And yes, it has a 9.9k record, so basically 9943 records. So if you are going to make any changes into the parent or into the child object, it is not going to impact each other. Sounds good? Now, If you guys remember, when I was explaining about the time travel, I say that how we can roll back our data. So we were discussing about the time travel, that how we can like query the previous or query the change record or updated record, whatever like you mistakenly you have updated it, and if you wanted to do a query or historical data. But the problem was how can we roll back or how can we like basically install that. The whole point is, just imagine this is an employee table. This is my final table used in reporting. Okay, but right now we do have a zero record. I do have a zero record. Now I wanted to reach in point of a time where this employee table was having 9,000 record so that I can share it with the Power BI or the Tableau people. In this scenario, what I'm going to do is I will be using time travel plus copy clone. So I need to use both time travel plus copy clone. So I'm going to write like this, create or replace. And let's say I'm going to take employee old, and this I have to use table. And here I'm going to write clone. This is going to be employee table. But here I will be writing at offset. You can use anything, minus 60 into 10. Now, what I have done, I have created a cloned copy of employee table, but 10 minutes ago. Sorry, 10 minute ago. Yes, 10 minute ago, because it's minus 60 and 60 into 10 by 600 seconds. Now, if you will look at it, then you will find select star from employee. Then this is going to have your correct data. It's 9.9k record. So we are one step closer that yes, we have that correct data, but the problem is this employee table is being used in Power BI. We cannot simply ask anyone that by please can you please update this table, right? Because there's some standard procedures that we cannot simply touch the data sources. I be in Tableau, be in Power BI, be in Looker or anywhere. So what can we do now? The best way is that you are going to write alter table, employee table, and then we can write swap with employee old. Now once you execute this, and now you see, if you're going to run select star from employee table, you will be having your entire 9.9k record. So that means if anyone is asking you to install or to basically reinstall that data, then we can simply say I will be using a time travel plus copy clone, and then that's how I can restore my entire data. After that, we are using the swap with keyword. That means whatever data we do have in this employee old, that will be going to the employee table. And then we are just like swapping, just kind of a swapping the variables. We are swapping the tables here. So that's how you can leverage your time travel plus copy clone to restore your tables, restore your data, and that before getting things escalated and all. Now, one of the last thing, one important question I do have for this time travel, which I generally ask in interview, and 99.99% people fail to answer this, that if I have one customer table with 100 columns, and that is having a 1 million record, now by mistakenly I created another customer table with 10 columns, then how will I reach to my previous table? If you think that the time travel we can simply go and use this offset and all, then this is not going to work. Wanted to check it out? Let's see that. So what I'm gonna do, I am going to create select star from customer. Yeah, let's say I do have this customer table. In this customer, I have around six columns. So consider these are the 6 column and 12 record. This is my correct data. Now by mistakenly, I have used a command create or replace table customers. And there I just use id int. Now, if I'm going to write select star from customers, what will happen? This is going to give me 0 record with just ID column. Now, most of you think that, okay, hey, Vishal, why can't we just simply go for the time travel? That means I can simply write at offset minus 60 into, let's say, 10. But what will happen? This is giving me time travel data is not available for table customer. The requested time is either beyond the allowed time travel period or before object creation. Because I'm trying to get the data of the customer 10 minutes ago, but if you remember, I just created this customer, recreated this customer table. So in this scenario, this Snowflake cloud service layer will try to go and find the basically we are asking to Snowflake to go back into the time travel and find out that particular micro partitions. But cloud service layer is saying, "Bhai, wait, hold on. You just have recreated the table." So in this scenario, the next step, what you're going to do is you will be first going to create alter table customers, and then you are going to rename it. Rename to, like, let's say this is old customer, something like that. And now you are going to run a command undrop table customers. Now if you will going to run it, select star from customers, and then you will be finding your 12 columns, sorry, the 6 column and your 12 records. This is one of the important and one most asked interview questions. So I'm sure you have understood that how you are going to leverage the time travel and the zero copy clone. If you really like this, like if you have enjoyed this session, then please like the video and share with your friends. Thank you so much.